In this video, I will talk about a technique on how to predict the bond angles. So let's just get started with a shape like this, which is a trigonal planar. So let's just consider that we have an atom in the middle called by A, and it is attached with three other atoms which is called by X. And because this whole shape, if we just draw a circle, just draw a circle like this. So this circle has an angle of 360. So if we divide it by 3, the angle of one side will be 120. So here will be 120. Alright. This is one thing important that you have to know. If we have a multiple bond, like here, if we have a multiple bonds repel more strongly than single bonds. So what it will affect now, that the angle here will be increased. So instead of it is 120, it will be bigger than 120. So the angle here will be bigger than 120. Also here will be bigger than 120. But here it will be bigger than 120, right? No, it will be smaller than 120, because these two sides are bigger than 120, so this should be less than 120. So let's have a good example of this to ensure that we are going on a correct path. So let's just have a formaldehyde, CH2O, and if we form this CH2O, we know that C will be in the middle, and we will have hydrogen here and hydrogen here. And another thing, because oxygen need to form two bonds to be more stable, so we will do a double bond with oxygen, and also carbon need a double bond. So this will be the shape. As you can see now, the geometry shape or the geometry structure of this will be a trigonal planar. So it should be 120 and approximately 120, but it is not 120 because we have here a double bond. So this double bond will make the angle, it's much bigger. So this angle will be bigger than 120. This is the same also, bigger than 120, and this less than 120. Now let's have a practical example. Here we should predict the angles between the central atom and the associating atoms. So the angle from here to here, what it should be, because we have an oxygen in the center with two lone pairs, and also it form an hydrogen from right side and it's attached with a carbon on the left side. So this shape is looking like the water structure, which is like this. And as we know, the angle for the water is 104.5. So the angle here will be 104.5, and this is the same, 104.5. Then what is the angle between this and this? Alright, so the angle between this and this is, this should be let's just ask ourselves, is this required to be 120 or not? Alright, so this shape is looking like this shape, a trigonal planar. So if we have like this shape, this is a trigonal planar. Alright, and we have here a double bond. So the angle here will be less than, the angle here will be bigger than 120, because the double bond will increase the angle. So this will be bigger than 120, and this is the same, will be bigger than 120. Alright, so because this is bigger than 120 and this bigger than 120, the third angle will be less than 120, as this is bigger than 120 and this is also bigger than 120, so this must be less than 120. Alright, so the last angle what we should extract is this, the angle of this, how much, and this and this and this. We know methane, this is methane. The bond angle here in methane is 109.5. So the shape looks like a methane. So this angle will be 109.5. This is the same, also 109.5, and this is the same, and as well as this, the same is.